Hi everyone, my name is Jussi Puura. I represent Sandvik, and I was asked today to give an industry view into the topic of AI and safety, kind of warm you up to the topic. I work at Sandvik Mining and Construction, big mobile mining machines, quite harsh environment. I've worked there since 2006 actually, so before I graduated, so I should know a lot about the topic. My job at the moment is working at Sandvik with the research and technology development, so it's kind of bridging the gap from academia to product, so maturing technologies, making new product concepts out of them and something we can actually sell. My biggest task at the moment is our next generation of autonomous equipment and the technology basis for it. Sandvik actually has delivered first autonomous mining equipment, I think it was 99 or 2000. So for 20 years we've sold autonomous mining equipment, and my job is to come up with the next generation. I'll briefly show a video of our latest concept machine. I think this is from 2 years ago, where we are heading with autonomous mining equipment.
Autonomy is revolutionizing the mining industry. You can expect the future to bring more. The next generation of autonomous mining is soon here, with equipment that finds its own way around, seeing everything better than you or I would see it, sensing what's there and what shouldn't be there. Machines that plan the best routes in a fraction of a second, making the right decisions, whatever the conditions, and leaving no emissions. You'll work the same mine, but in so many different, smarter ways. The next generation of autonomous mining, faster, easier, and a lot more productive.
All right, so that's our concept machine, real working prototype of our vision of the future. Where we see this going is, cabinless, fully electric, unmanned, adaptive, and safely working with people and other machines. I'll try to look at safety and AI from 3 directions: safety in AI, safety and AI, and then AI in safety. So that's what we'll see next. I'll show a little bit of our intermediate results of how we got where we are now at the same time. So naive approach to safety, AI, why would we do AI? People are great, they are creative, they learn, they get better, they are adaptive, but they get tired, they need breaks and so on. Then you have one Kimi Räikkönen and then the rest of us and then some other people. So it would be nice if you could replace the person with something that's creative, learning, adaptive, and you can copy the Kimi Räikkönen and put him in every car. That's the naive approach. And of course this is not a product architecture, but you can try this, and we have tried it. This is one of our intermediate solutions from 2019. It's actually AI that sees the sensors, sees the speed, sees the steering, sees the location, and then directly controls steering and velocity, and adapts to the situation, learns the machine dynamics, learns causes and effects, forecasts what the sensing might be in a moment, what I suspect that I will see in a moment if I continue like this, makes possible futures, optimizes those futures and selects the best future, and then actuates that into steering and velocity. It works great. It can find its targets and adapt like a human to what it sees. We also tried this actually so that we taught it in a simulator and then tested it against our actual control system. So here's our actual loader with the actual physics, and it turns out to work quite well. So replaces the path planning and control with a learned AI. But this is not the solution we went with on the concept machine. And the reason is that this sort of AI is reactive in a sense. I can't say what it will do in 0.2 seconds. And after that, will it make a mistake that it can't recover from? If it did something, why did it do something, and can I replicate it, and so on? Can I live with it as a normal service guy for 10 years on the market, on every mine site, and so on? So the creativity, living in the moment, is the biggest pro and con. What we actually did is we used the same-ish solution and got the creativity and adaptivity, but in planning. And then we use good old-fashioned control theory to execute the plans with very good precision. Because we are really good at that, and that I can explain. Plus this I can reuse. I can drive these paths autonomously, but I can use them in planning, guidance, helping people make better solutions as well. Plus the AI can make a creative solution, and I can check the solution with traditional understandable metrics and make sure that it's safe, and then allow it to be executed. And I can reuse this. It's not a big monolith, but a clean, nice solution that I can reuse in other places. I wouldn't build the safety into the AI. How can I explain it? It gets too big. But what I would do is shown here with our real concept machine. So let the AI be creative, let it do the job as well as it can, and then have another system there on the allowing it or denying it, and if the AI wants to drive full speed in a circle, let it, it's okay. If it's about to lead to a collision, let's stop it. But have the AI learn that the safety system will stop you if you do this sort of things. So, but that's something that I could actually maybe achieve and sell, this kind of like a bystander safety system, or kind of a monitoring safety system. And can that then, this smaller system whose target is now not to make the right decision, like fail operational all the time. It's not like if I stop controlling the machine, a plane will fall from the sky. It's always safe to stop. This guy has much easier job. Does it look dangerous? Can I allow this to continue or just stop? Easy decision. And if I make 20 of those decisions in a second, and my from detection to danger is 2 seconds, if I do 18 correct decisions and one that says that 18 say that it's dangerous, 2 say that it's not dangerous, I'll stop the machine and it's going to be safe. So this sort of systems I can live with. And if I had this kind of safety systems on the side, does it really matter if it's artificial intelligence or real intelligence? So we can also make the people safer with this kind of systems. Now, AI in safety is really interesting as well. If you keep the safety concept simple, you ask a small enough question, like is there a person in this picture? If there is, we'll stop. It's much harder to ask what's the right decision, steering decision to do in this moment. But it's much easier to ask that is there a person in the danger zone? Should we stop? and rethink, replan, restart, and so on. And this is excellent technology. Our environment changes, it's always different. Really complex situations, moving booms, hydraulic hoses, and so on. Tell me one other technology that can detect that person there without putting a marker on that person. So I think this is the best technology for this problem, detecting a person in danger. But for some reason I can't use it at the moment in safety systems because I can't prove it or explain it. So looking forward to, for example, Saeed's work on that topic. Maybe in a few years we can do a safety product this way. All right, that was my last slide into the topic. Questions?
We have time for